Hi, I'm Luke Goembel, owner of Goembel Instruments. I'm going to talk about the spacecraft charge monitor flight qualification tests. 5 tests were performed on the spacecraft charge monitor to prove that it was ready for flight. The first test was a vibration test, which simulated the vibrations expected at launch. The second was a thermal vacuum test, which simulated the vacuum and the temperatures expected in outer space. The third test was a test to see if the spacecraft charge monitor could determine floating potential when mounted on a spacecraft. The fourth test was a gauge of the electromagnetic noisiness of the spacecraft charge monitor. And the fifth test I'll talk about was the laboratory test of the function of the spacecraft charge monitor, which was done periodically throughout the development of the device. Before the SCM was built, careful consideration went into designing it so that it would withstand the vigors of space. The electronics boards included staked components and conformally coated boards to assure their long life in space. All of the parts of the SCM were very carefully assembled before any of the tests were performed. The first test I'll talk about is the vibration test, which was subcontracted to the Johns Hopkins University Applied Physics Lab. The spacecraft charge monitor has been vibration tested to a qualification level of 14.5 Gs. The 14.5 G qualification level assures us that the SCM could be launched from many launch vehicles. Now I'm going to talk about the thermal vacuum testing of the SCM. The thermal vacuum testing took place in the Goembel Instruments laboratory. The test apparatus consisted of the SCM, the thermal control for the test, and an electron source so that the function of the SCM could be determined throughout the test. Sensors were attached to the outside of the SCM, as well as having a sensor on the inside of the SCM. A thermal blanket aided in the cooling and heating of the SCM during the tests. The SCM was tested over 6 cycles over a total time of 41 hours, where the temperature was varied from -24 to +61 degrees centigrade. Data was gathered by the SCM during the test to determine that all of its systems were working properly. The spacecraft charge monitor was tested at NASA Kennedy Space Center in Florida. The SCM in a test mount was delivered to NASA. They installed it in a vacuum chamber and tested it to see if it could in fact determine the floating potential of a spacecraft. The SCM was floated from -145 to 45 volts to see if it could collect spectra that would then be used to determine the floating potential. It did in fact determine floating potential accurately. While the SCM was at NASA Kennedy, it was also tested for electromagnetic interference. When the SCM was tested for electromagnetic interference, none was found, showing that the SCM was electromagnetically quiet, which means it will be compatible with other instruments on a payload. The final test that I'll talk about is the electron gun test, which took place in the Goembel Instruments laboratory. This test was done throughout development of the spacecraft charge monitor to show that the spacecraft charge monitor could in fact detect the signal that was needed to determine spacecraft floating potential. There's a video that shows this test actually being done in the laboratory that can be accessed by going to the Goembel Instruments website. Shown here is a typical 1-second spectrum collected by the SCM during testing. For more information about Goembel Instruments and the spacecraft charge monitor, go to www.goembel.biz. Thank you very much.